Hello class, this is a video tutorial on multi-stage probability part 3. In this video we'll be looking at replacement and removal. For certain multi-stage chance experiments, the result from one stage affects the probability of the following stages. One example of this is a raffle draw, since a ticket being drawn means fewer tickets in the following draws. Here's an example. Gavin buys 2 tickets from a pool of 100. 2 tickets are randomly drawn, one for first place and the other for the runner-up. Let's create a probability tree modeling the scenario. Well, in this scenario, Gavin could either win or lose. In this case, I'm going to say it's a not win. So this is for the first prize. So first prize, draw. And this will be for the second prize. Following this path, he could win or he could lose the first prize. Now let's calculate the probability that he wins the first prize. Well, in the first prize, he has 2 tickets out of the total of 100 tickets. So he has a 2 out of 100 probability winning, which means the probability that he loses is 98 out of 100. Let's continue drawing up this probability tree. After Gavin wins, he could win the second prize again. Or he could lose, so not win. Well, let's now think about the probability that he wins again. Considering that he's already won the first place, that would mean he has 1 less ticket left to win. So he has a total of 1 out of. Now, the 100, this is actually incorrect because in the first draw, a ticket has already been removed, one of them being his own. So there's a total of 99 tickets left, which means the probability that he loses is going to be 98 out of 99. For when he loses, he could win after he loses the first place, or he could lose again. The probability now that he wins after he's lost the first one, let's think about this. If he loses the first prize, that would mean he still has 2 tickets left in the draw. However, the total number of tickets has been reduced by 1 because a losing ticket has been removed. So he has a 2 out of 99 chance of winning the second prize. For him losing the second prize, well, he still has a 97 because 2 and 97 make 99 out of 99 chance of losing. So this here is a completed probability tree of Gavin's scenario. So let's calculate the probability that Gavin wins both prizes. So this is a probability of win-win, WW. Well, WW would be following this path here. To get to that path, that's 2 out of 100 times 1 out of 99. So multiplying that, 2 out of 100 times 1 out of 99. Straight to our calculator. 2 out of 100 times 1 out of 99. That's a very small number. I'm just going to leave it as a fraction for this one. That's 1 over 4950. So he has a 1, almost in a 1 in 5,000 chance of winning both first and second prizes. What's the probability that Gavin wins no prizes? Well, winning no prizes means he loses the first and he loses the second. Well, that is the same when we do it in notation. Probability of not win, not win. Following that probability, that's 98 out of 100 times 97 out of 99. This I think will be a very large number. Let's just calculate it. 98 out of 100 times 97 out of 99. Leaving it as a fraction, that's 4753 over 4950. What's the probability that he wins at least one prize? Well, winning at least one prize, he could win both. He could win the first and lose the second. Or he could lose the first and win the second. So that's the same as probability of win, win, plus the probability of win, lose, plus the probability of lose the first and win the second. We already have this probability. Not going to calculate it again. 4950 plus, calculating this, I'll do it up here. Win the first, lose the second. That is 2 out of 100 times 98 out of 99. And lose the first, win the second. Calculating that, that is 98 out of 100. This one here. Times 2 out of 99. Let's calculate both. And 98 out of 99, 100 times 2 out of 99. Oh, would you look at that? It's the exact same thing. So that's going to be 49 out of 2475 plus 49 out of 2475. Adding all of these. So 1 out of 4950 plus 2 lots of 49 out of 2475. In total, that is 197 out of 40950. Well, I hope that gave you an insight into calculating a event where we replace the objects and we remove the objects from the probability tree. I'll be doing another example just right after this, so I hope to see you then when I do this example. Best of luck.